Section F, problem solving with quadratics. Step 1. If information is given in words, translate it into an algebra using variables. Okay? Those variables, make sure you write down the resulting equation you get and you define the variables. Don't forget your units and measurements. Step 2. Solve the equation by a suitable method. That means any method that you need to. Step 3. Examine the solution carefully to use if they are acceptable. Step 4. Give your answer in a sentence. The best way to learn problem solving with quadratics is through examples. So I'm just going to do a few. This first example, a rectangle has length 3 centimeters longer than its width. Its area is 42 centimeters squared. Find its width. So I'm going to let W equal the width of the rectangle in centimeters. Notice I've included the units of measurement. So that means my length would have to be my width plus 3. So I'm just going to write length is width W plus 3. Then I look at the other information given to me. Well, I know I have the area is 42 centimeters squared. So I'll remind myself, what's the area of a rectangle? Well, that's length times width. So that means my area would be W plus 3 times W. I know area is 42, so I'm going to replace A with 42 centimeters squared. And then I'm going to multiply out the W, rewrite the quadratic so it's equal to 0, and solve. You can solve these any method that you want. Just to save time, I'm going to use my calculator and then use the calculate function and find my zeros. But you can use any method we've learned this section to solve these quadratics. So go to your y equals, put the equation into your y equals equation, and then sketch the graph. Always start with the zoom standard so we get an idea of what the graph looks like. Now technically I see my x-intercepts, so this graph is fine, but a lot of people like to see the U shape, so I'm going to go ahead and just change my y-min so that I can see the entire parabola. Now I need to calculate the two x-intercepts, so that's my solution of this equation. So remember, we go to second trace, zeros, move the cursor to the left of the 0, enter, move the cursor to the right, enter, enter. There's 1 0, negative 8.15. But negative 0.815 would be the length of the width. Now, does it make sense for the width to be a negative length? No, it doesn't. So this is what I mean by analyzing a solution. So I would mark this one out. I do need you to write it down, just put an X through it so that I know that you found it. Okay, we're going to repeat the process and find the other 0. So second trace, 0, enter. Move the cursor to the left of that 0, kind of close to it, but to the left of it, where the x value is less than the x value of the 0. Enter. Now move the cursor to the right of the 0, enter, enter. And we got 5.15 as a solution. So on my work, remember, you write these both solutions down, and then you X out the one that does not make sense, and then write your answer in a sentence form. So the width is about 5.5 centimeters. Make sure you use units of measurement when your final answer. Example 2. Is it possible to build a 12 centimeter long wire? So let's get the information. So we know the width of the wire, the length of the wire is 12 centimeters. To be perpendicular sides of a right angle. So let's draw a little picture. So we got this right triangle going on in here. And that right here, these two sides is the wire. So let's make one length x. So that means this one has to be 12 minus x. So we'll let x equal the height of the triangle in centimeters. We'll let 12 minus x represent the base of the triangle. And we also know the area is 20 centimeters squared. So let's do the area formula of a triangle is 1/2 base times height. So that's area is equal to 1/2 12 minus x times x. Multiplying, replacing the 20 in place of the x and multiplying 12x by each term. Get this quadratic equal to 0 by subtracting the 6x and adding the 1/2 x squared. Solve this any way you want to. So I want to know, is it possible? So to know if it's possible, I need to know, does it have any x-intercepts? And I know if my determinant is less than 0, we do not have any x-intercepts, so it will not be possible. If the determinant is greater than or equal to 0, it is possible. So that means all I have to do is find the determinant. I don't actually have to solve this quadratic. I just need to find the determinant. So identify my a, b, and c, plug it into my b squared minus 4ac squared AC formula, b squared minus 4ac formula. I find my determinant is a negative number, -4 to be exact. So since my determinant is negative, I know it is impossible for me to form a right triangle that has the area of 20 centimeters, given only that 12 centimeter long piece of wire. So I'd say it is not possible, and that would be my sentence answer.